Okay, in this video we're going to discuss structural formulas and talk a little bit about some of the issues that are going to arise when naming. We're not going to talk about naming in this particular video, but we are going to kind of hint upon some of the issues there. So we're going to look at page 270 and number 65, and we'll do B and C. Okay. All right, so in this question, it is asking us to provide a skeletal line structure for the following Lewis structures. B seems a little bit harder than C, so let's start off with C. Okay, so C, we have 4 carbons, and off of the second carbon from the left, we have another carbon right there. Let's fill all the places with hydrogens. Remember, carbon can form up to 4 bonds. It's going to share up to 8 electrons. So we should always look for 4 bonds around carbon, whether 4 singles, 2 doubles, 1 triple, 1 single, 1 double, 2 singles, things like that, arrangements like that. Always look for 4 things around carbon, whether it be single bond, double bond, and a double bond. So just count up the number of lines and you should get 4 always. If you don't have 4, there's an issue. Okay, so let's take a look here. Let me change colors. Now we have 4 carbon atoms in a row. This backbone is going to be 4 carbons. We could scan across left to right. We see 4, 1, 2, 3, 4. 1, 2, 3, 4. We can even go from right to left and go down 1, 2, 3, 4. No matter what we do, there's always going to be 4. All right, so skeletal structure. Each of these spots, 1, 2, 3, 4, are going to correspond to each of these carbons. Now, off the second carbon, we have the 1 carbon right there. That is a methyl group, and I'm going to put this in turquoise. All right, so off of that second carbon, we have a methyl group, and it's just 1 carbon, so we draw a line down there, and there's our carbon, and this is our skeletal structure for this particular arrangement of atoms in space. This one is particular, would be 2-methyl butane. We'll talk about naming in a later video, but I just want you to start seeing that. All right, let's go to my normal color here. Let's go to B. B is a little bit bigger than this one, so let me scroll down a little bit and let me redraw this molecule. Looks very similar. It has 4, has the carbon coming off, but has a carbon coming off the top there then as well. Let's fill hydrogens all around each of these as shown in the problem. Notice I'm not drawing the dashes. You could, but I'm just trying to save time and writing frustration potentially, but I will for this one. All right, so let's take a look here. I'll go back to pink. So no matter what we do, we have 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. No matter what order we go in, we're not going to have any more than 4 carbons in a row. We can go 1, 2, 3. That's not going to help us though, because we always want the longest chain, and you're going to be doing that for naming. You want to find the longest chain. So 4 is the longest chain here. So we can do again 1, 2, 3, 4, and we can number these 1, 2, 3, 4. I can rewrite this out. So when we color code, we can see what we're actually looking at. All right, now we have off of that second carbon again, up top, we have one carbon. All right, so a line straight up is going to give us that one carbon. And again, we have that same carbon coming down. We did it in turquoise before. We'll do it in turquoise again. There. Now, of course, you're not going to have all these different colors for your problem if we were just doing it outright. Let's see. Let's get maybe a red. We would just have something like that. Okay. We don't need to color code it. It's not appropriate to color code it. I'm color coding it so you can see what each line is pertaining to. All right. Well, there you go. I hope this helps you see what these skeletal structures really mean.